S1 center is 80, requirement of S2 is 120 and requirement of S3 is 150. Total requirement is 350, while supply of 4 factories are 10, 150, 50 and 100. It means 310. So problem is for maximization and also problem is for unbalanced problem. The two situations are simultaneously in this problem. And our main aim to determine most profitable production and distribution schedule. So we need corresponding its profit. So this situation can be solved by first we calculate the profit. The formula of profit equal to sales price minus production cost minus raw material cost minus transportation cost. Different sales department selling price are given, production cost for factories, raw material cost from factories and transportation cost from different factories to sales departments are also given in the question. So related payoff table for profit is 661 minus 2 minus 2 minus 4 322 853 with requirement and availability. Now this profit table we convert in loss table. Otherwise this maximization problem we convert in minimization problem by select highest profit is 8 and subtract all the corresponding profit from it. We get the profit table as convert in loss table as a 2, 2, 7, 10, 10, 12, 5, 6, 6, 0, 3 and 5. This is the situation we convert maximization into minimization. But now there is a problem for unbalancedness. So we add one artificial row with 0 transportation charge with 40 units of availability. Now this problem convert in minimization simultaneously in balancedness. And we solve by northwest corner rule method. Our first northwest cell is F1 S1. There is a availability of 10 units while requirement of 80 units. So we allocate minimum terms from both this is a 10. So we availability of F1 factory is satisfied. We cancel first row and there is a requirement of 70 units are there. Now northwest cell is F2 S1. There is a availability of 150 units and requirement of 70 units. So we allocate 70 units in that cell and now availability of 80 units are there. Requirement is satisfied of S1 cells depot. Now northwest cell is a 4 by 2 and particular cell is F2 S2. In that cell availability of 80 units and requirement of 120 units. We allocate 80 units in that cell. So availability of F2 is satisfied and requirement of still 40 units of S2 is there. Now reduced matrix is of size 3 by 2. Northwest cell is F3 S2. There is a availability of 50 units and requirement of 40 units. We allocate 40 units in this cell. So requirement of S2 is satisfied and 10 units are available. Now there is a order of matrix is 1 by 3. Exactly one column is remain satisfy all requirement as 10, 100 and 40 and satisfy requirement of 150 units. This is the solution by northwest corner rule method. So now our aim is to maximize the profit. So 10 multiply with 6, 70 multiply with minus 2, 80 multiply with minus 2, 40 multiply with 2, 10 multiply with 2 and 100 multiply with 3. We get maximum profit as 160 by northwest method. So this is the 3 types of problem we study by northwest corner rule method. Now our next method is matrix minima method, न्यूनतम श्रेणिक रीत, otherwise list cost method, otherwise a method of inspection. Our objective of TP problem is to minimize total transportation cost, and hence we must try to transport as much as possible through those routes where TP charge is minimum. Necessary steps are as follows. Step 1. Such cell with minimum TP cost from the entire matrix and allocate as much as possible to this cell and eliminate the row if supply existed or column for which row is fulfilled, or both row as well as column. If supply and requirement fulfill in the case of tie among minimum charge, select that cell where maximum allocation is possible. Step 2. After adjusting supply and demand for reduced TP table, repeat the procedure given in step 1. Step 3. Repeat above procedure until entire available supply at various origins and demand at various destinations are satisfied. The advantages of these methods are: first, it takes into account TP charge and hence method is more reliable compared to northwest corner rule method. Second one is simple and easy to apply. Third one, it does not take into account the penalty associated with improper allocation. Now we just take one example of balanced transportation problem. In this situation, there are 3 plants P1, P2 and P3 and 5 warehouses W1, W2, W3, W4 and W5. There is a availability of 50, 100 and 150 units. The total availability is 300 units. Simultaneously, total requirement is also 300 units. Here the problem is balance problem. Now we solve this problem by using list cost method, otherwise matrix minima method. In this method, smallest TP charge is 20. Here available 50 units and requirement of 100 units. So we allocate 50 units in that cell. Now requirement of 50 units still there. Now from the 2 by 5 matrix, the smallest TP charge is 22. Here availability 150 units and requirement of 50 units. So we allocate 50 units in that cell. Now reduced matrix is 2 by 4. From this 2 by 4, smallest TP charge is 25. Here 40 units of requirement and 100 units of available. We allocate 40 units in that cell and remaining value is 60. So we cancel this column. Now reduced matrix is of size 2 by 3. Among them, smallest TP charge is 35. There is a requirement of 50 units and availability of 100 units. We allocate 50 units in that cell. And now reduced matrix is of size 2 by 2. The smallest TP charge is 36. There is a available 60 units and requirement of 70. We allocate 60 unit in this cell. And now remaining work is 10. Now reduced matrix is of size 1 by 2. We satisfy rim requirement. Here there is a requirement of 10 units and requirement of 40 units. Both are satisfied. Then transportation cost by list cost method as a 20 into 50, 36 into 60 plus 25 into 40 plus 35 into 50, 55 into 10 plus 22 into 50 plus 45 into 40. Then total transportation cost is 9360 rupees by list cost method. Now there is one unbalanced problem of transportation problem. There is a requirement of 250 units and available 220 units. So solution of this problem by matrix minima method, we just convert in balance by adding one artificial row with 30 units of transportation, 30 units of available and 0 transportation charge. So our availability becomes 250 and requirement is also 250. By matrix minima method, we just observe the smallest TP charge. Here smallest TP charge is 0 in the 5 situation. So we select arbitrary any one, but due to technique, our I plus j rule, the highest position is this 0 and there is the available 30 units and requirement of 80. So we cancel row and satisfy 30 units in that cell. Now reduced matrix is of size 3 by 5. Again we observe there is a smallest TP charge is 3 in 2 position. In first position we can allocate 50 units. Simultaneously in third position we can allocate 50 units. But I plus j rule says that we just have to select the CT cell. So in this cell we just allocate 50 units. And now reduced matrix is 3 by 4 and again there is a smallest TP charge is 4 in 2 cases. In first cell B to P, the 40 units allocation is possible and C to Q 40 units of allocation is possible. So in both the situation, number of allocation and TP charge both are same. We check the highest position. So highest position is a C to Q. We cancel row and column wise 40 units and we can make one artificial allocation epsilon because row and column both are simultaneously cancelled. So in this situation 8, 7 and 4 and 4, 6 and 6, the 8, 7, 6, 6 from 4 position the smallest TP charge is 6. We can select any one as a allocation of artificial. Now reduced matrix is of size 2 by 3. The smallest TP charge is now again 4. We allocate 40 units in that cell. Remaining is a 10. Now reduced matrix is of size 2 by 2. The smallest TP charge is 6 in 2 position. We select position wise. First position we can allocate 40 units and in second position we can allocate 10 units. So we allocate maximum units as a 40. And now there is only one column remain. We allocate 40 units in first cell and 10 units in the second cell. So all supply and all demand are satisfied. And the solution by this problem by least cost method, matrix minima method is 8 into 40 plus 6 into 40 plus 4 into 40 plus 7 into 10 plus 4 into 40 plus 6 into 0 plus 3 into 50 plus 0 into 30 is 1131110. This is the solution by matrix minima method. વિદ્યાર્થી મિત્રો તમને આ બંને રીતો વાયવ્ય ખૂણાની રીત એટલે કે નોર્થ વેસ્ટ કોર્નર રૂલ મેથડ અને લિસ્ટ કોસ્ટ મેથડ બંને સારી રીતે સમજાણી હશે એવું માની અને નેક્સ્ટ લેક્ચરમાં આપણે આની ત્રીજી મેથડ છે નોર્થ વેસ્ટ કોર્નર રૂલ વોગલ્સ એપ્રોક્સિમેશન મેથડ એને આપણે સમજીશું અને ભણીશું. આપણે અને સાથે સાથે નેક્સ્ટ લેક્ચરમાં આપણે રિપ્લેસમેન્ટ પ્રોબ્લેમ પણ ઓપરેશન રિસર્ચના એક ભાગરૂપે એને પણ આપણે સમજીશું. આપણે ખૂબ શાંતિથી અમને લોકોને બંનેને સાંભળ્યા એ બદલ આપનો ખૂબ ખૂબ આભાર. થેન્ક યુ વેરી મચ. હેપી સંક્રાંતિ અને હેપી કાઇટ ફ્લાઇંગ ડે ટુ ઓલ ઓફ યુ. થેન્ક યુ.
संधान ઓલ ગુજરાત ઇન્ટિગ્રેટેડ ક્લાસરૂમ.
સેટેલાઇટના માધ્યમથી જોડતી કડી એટલે સંધાન.